Okay, you're given a problem about the production of water ski vest, and they give you the cost function as well as a domain where x is the number of water ski vests produced, so it has to be between 0 and 150. The first question, part A, asks you to find the average cost, which how you find average cost is you take cost and divide by the number of units. So I'll take the cost function, 25x plus 405, and divide by x. I can make this look a little better by dividing each term by x, so I end up with 0.05x plus 25 plus 405x, and that gives me my average cost function. Alright, part B wants you to find the critical points of this average cost. Well, to find critical points, you have to find the derivative. So I need to find this derivative of this average cost. And so I can see that the derivative of 0.05x would just be 0.05. The derivative of 25 will be 0, so that goes away. The derivative of this piece, you can rewrite it as 405x to the negative 1. So you bring down the negative 1, that's how this becomes negative, and then you subtract 1 from the exponent. So that would be the derivative. I could rewrite it as 0.05 minus 405x squared. After you find the critical points, after you find the derivative, you set the derivative equal to 0. So 0.05 minus 405 over x squared. And then you solve this for x. So what I'm going to do is I'm going to move this 405x squared to the left-hand side of the equal sign just to make it positive. So I just added it to both sides. Then I'm going to multiply x squared on both sides. So I end up with 405 equals 0.05x squared. I'm then going to divide both sides by the 0.05. That's going to give me 8100 equals x squared. And remember, when you square root both sides, you're doing the plus and minus. So that's going to give me a plus and minus 90. Well, I ignore the minus because way up here somewhere, way up there, that's not in my domain. 90's in my domain, but negative 90's not. So I can see the only critical point is at x equals 90. Alright, then it asks you the average cost per vest is decreasing on a particular interval and increasing on a particular interval. Well, how you find that is you take the critical point, 90 that we found, and you pick a value to the left of it, like, I don't know, how about 89, and you plug it into the derivative, because the derivative is going to tell you if it's increasing or decreasing. So I'm going to plug in, all I have to do is just pick a value to the left. I'm going to plug in 89, and then pick a value to the right. I'm going to plug in 91. And again, I am taking this, if I can get it where you can see it, I am plugging these values into the derivative. If you do that, I don't care what the numbers are, but you will see this gives you a negative value and this gives you a positive value. So if I plug 89 into this function, I get a negative value. If I plug 91, I get a positive value. So that means it's decreasing from, don't forget your domain. So your domain was from 0 to 150. So it's decreasing from 0 to that critical point, and then it's increasing from that critical point 90 to the top of my domain. So from 90 to 150. All right, and then finally it says, is this a local max, a local min, or neither? Well, if I just think about this graph, if it's decreasing and then it hits a critical point at 0 and then it increases, okay, so there's my critical point. I can see just by this that this would be a minimum. And so what I want to do is, this is for back to the average. I go back to my average function. Okay, so that's the 0.05 x, and I plug in 90 plus 25 plus 405 over 90. And if I plug that in, I get my average cost of $34. And again, this is a local minimum.